In our previous lesson, we very briefly described how programs get stored in computers' memory and how they get executed, and then we drew analogy between learning a natural language like English and a programming language like C. Now in this lesson we are going to have some real action. We are going to write our first program in C. It's a tradition that whenever you learn a new programming language, the first program that you write in that language is to print hello world on screen. So let's write this program. The first thing that we will need is an editor in which we should be able to write our program. What I will do is I will not use any special editor. I am on Windows machine, so I'll just open Notepad, and if you are on some other system like Linux or Mac, you can open an editor of your own choice. And now I can start writing my program. The first line that I will write in my C program will be this: pound sign and then include and then this less than sign and then stdio.h, and then you have a greater than sign, so stdio.h is within angular bracket. Things are case sensitive here, so make sure you write everything in small letters, lowercase letters. This line is saying that I want to use the functionalities of a C library that we call standard input and output library, or just stdio.h. I will come back to explaining what a library is. I'll just move on for now. The next line that I'll write is int, then space, and then I'll write main, and then I'll open a parenthesis and close a parenthesis, and then I'll go to the next line and type an opening curly brace, and then on the next line I'll type a closing curly brace. We will write this much of code in all our programs. This is basic skeleton, and now I'll quickly explain what we have really done here. A C program is organized in entities that we call functions. You must be knowing of functions in mathematics. Let's take example of a mathematical function. Fx equal x square is my function. You can imagine a function to be a box that will take something inside and give back something else. It will give something else applying some rules. To this function fx equal x square, if we will give this function 2, it will give back 4. If we will give 5, it will give back 25. It will give back square of the number. You can think of a function in programming something like this. You can give a nice name to your function, and then you can define what all the function will accept inside it. Whatever you give to a function in C is called argument, and you can have more than one argument. You can have arguments, and whatever you get back from the function is called return. In our program, whatever we have written so far, these lines after hash include stdio.h are basic structure of a function. First line of a function contains definition of the function. The first part in definition will tell you what the function will return. Int here means that the function will return integer, an integer. Before the start of parenthesis, what we have is name of the function. So this function has name main, and right now there is nothing inside the parenthesis, but inside the parenthesis you define what all the function will accept inside it, what all the function will accept as arguments. A function may not need arguments, and a function sometimes may not return anything. After the definition of the function, we must have an opening curly brace, and then we can have some statements to perform some task. We can have as many statements as we want, and after all the statements we must have a closing curly brace. Closing curly brace will mark the end of function. Whatever is in between the opening brace and the closing brace is what we can call the body of the function. Statements are executed sequentially. A function in a program is basically an entity that can perform a specific subtask. In a C program, you must always have a function named main. The execution of your C program always starts with first statement in the main function. You can write a function of your own, but there are some pre-written and pre-implemented functions in C to perform some important tasks, and these functions are organized in what we call libraries. This first line hash include stdio.h is basically saying that I'm going to use some functions that are defined in stdio.h library, which we also call standard input and output library. This library contains a function named printf that will print something. Now I'm writing a statement that will mean making a call to printf function. To call a function, you first need to write the name of the function. Then within parentheses, you must give arguments, if any. To printf, you can give argument like this. Within double quotes, write whatever you want to print. I want to print hello world. Every statement in C must terminate with a semicolon. It's a rule, so we have put a semicolon here. There is one last statement that we need to write and we will be done. Main is defined to return integer. To return something from a function, you use the keyword return, and then after a space, you write a constant or variable name that will contain the value to be returned. At the end of your main function, you must write this statement return 0. For any other function that is defined to return integer, if you would not have an explicit return statement like this, you will get error. But for main function, even if you will skip writing this return 0, your program will work. It is good to write this for the sake of consistency. Okay, so this is all we need to print hello world. Now what I'm going to do is I'll save this file. In the save dialog, select file type as all files and then give a file name something.c. I'll give file name hello world.c. So I just created a C source file with a program to print hello world. And now we need to compile and run this program. To compile, we will need a compiler. I'm going to use a compiler named GCC, which is a standard compiler for C. On a Linux machine, you do not need to install GCC. It's already there. On Windows, you will have to install GCC. You can check the description of this video for a link on how to install and configure GCC for Windows. I am on a Windows machine and GCC is configured for me. To compile using GCC, I first need to open command prompt in Windows. Press Windows plus R key to open this run dialog and type in cmd and then click OK. Command prompt will open for you. Type in GCC and press enter. If you get a message like GCC no input files, then GCC is configured for you. If you get a message like command not recognized, GCC is not correctly configured. Now you must be remembering in which directory you had saved your source file. For me, it's in my code directory in C drive. There is this file hello world.c. In command prompt, I first need to go to this directory. So I'll say cd for change directory and type in the path. Now I'm in my code directory. And now I'll type in GCC and the name of the C file. For me, it's hello world.c. You can type this same command on a shell in Linux. If you hit enter and no message comes, your program has compiled and an executable has been generated. By default, an executable named A is generated. This is a.exe on Windows. On Linux, a file named a.out will be generated. In Windows, you can double click and run this file. But if you will double click, something will flash and go away. This is because program starts execution and before you can see the output, it finishes. For your machine, running a simple print statement is a task of milliseconds. If you want to see the output, you can run the executable from command prompt itself. Type in a.exe here. On Linux, you can run a.out, and when you will press enter, you have the output here. If you are able to do this much, congratulations, you ran your first program in C. Please note that there are a lot of compilers that give you very nice UI in which you will have an editor, and within the UI itself you will be able to compile and run your program, and there will be a lot of cool features to detect errors in your program. We call these compilers integrated development environments or IDEs. We will show you how to work with some of the IDEs in our next lesson. This is it for this lesson. Thanks for watching.